Okay, this is web feed for controlling tension, then through nip rollers and out to some process. Okay? Now, this motor is typically going to be a master in this case, and it's going to spin along and pull this material off. But they want the tension to be constant, so they put this dancer arm on here to just control tension. The problem is, it can only control it within a certain bandwidth. Because as this material comes off of here, and this gets smaller and smaller, this motor has to go faster and faster. So what we do is we run an electronic gearing. We take the electronic gearing, the encoder signal out of here, feed it back into this motor, and we gear off of that. Now, some people would say, well, as it gets smaller, you have to gear it faster and faster. Well, that's all fine and dandy. I can guarantee you nobody in production puts a sensor on here to measure what the radius of this is. They just don't do it because it's more expensive and they're not going to spend the extra $35 to do that. Okay? So, for whatever reason, they don't. So what we suggest is you take the position of this dancer arm and do a velocity override to compensate for the difference. Okay? Now what you've got is an analog feed in here that's taking this up and down and changing the velocity on top of electronic gearing to keep a constant tension. That way, even if they change the rollout and put a new material roll on there with a full supply, it will automatically start compensating. So all you need is a gear ratio that's somewhere between the average large and empty roll. Somewhere in there will do. After that, the analog feedback from this will do a velocity override on top of gearing and do just fine. Okay, now some people would say, why don't you just change the gear ratio with that angle? There's a reason you don't want to constantly change the gear ratio. It's going to jerk around a lot more if you do. Whereas if you do electronic gearing and you're constantly following this speed, if it speeds up or slows down, the main speed will always be predicated by how fast this one goes. But any offset will be compensated by the velocity. So you're less likely to get a jerk or a sudden change in speed. It's going to be a lot smoother by doing it this way. That's dual trajectory mode operation right there. The first trajectory is actually running in velocity mode. The second one, when I say first and second, it's just number one and number two, is running in gear ratio.